Hello and welcome to this math class. We have this question here. The question says bracket m plus 7 close bracket all to the power of 7 equal to m to the power of 7 plus 7 to the power of 7. So what is the value of m here? So let's see how we solve for this. All right, so we take our solution. All right. Okay, so the question here we have m plus about 7 all raised to the power of 7 equals to m to the power of 7 plus about 7 to the power of 7. Now this is a heavy exponent. So how do we solve for this? We're going to think of some algebraic identity that will enable us to solve for this. Okay, so I have to make research to getting expression of this kind in our algebraic identity that will enable us to solve this. And I came up with this. We have this, that if we have our bracket, let's take our x right here, x plus our y all raised to the power of 7, this is equal to, we have our x raised to the power of 7, then plus 7xy, the bracket, our x plus y close bracket, then bracket our x to the power of 2, then plus our xy plus our y to the power of 2, then close bracket, all raised to the power of 2, okay? Then plus our y raised to the power of 7. Okay, so I was able to come up with this algebraic identity. So with this algebraic identity, then we can solve what we have in here. Okay, so let's rule this of this what we're going to use. Sorry, in solving this expression. So this side of our equation is of this form. So we have to rewrite this expression in this format, keeping this side of this. So this now implies, so with here, we have our x to be m and our y to be 7. So this can be written, again, we want to express this side in this form. So this is going to give us our m to the power of 7, then plus our 7 times our m times our 7, okay? Because our y is 7, then bracket our m plus our 7 close bracket, then bracket our m to the power of 2 plus our m times 7, then plus our 7 to the power of 2, always to the power of 2, then plus our y is 7, right? So we have 7 to the power of 7. Mind you, everything here is equal to this. So this is equal to our m to the power of 7, then plus our 7 to the power of 7. Okay, so from here, you discover that we're having m to the power of 7 on this side, positive, and we're having m to the power of 7 on this side, positive also. And so this, we go with this. So if this cancels this, then we check out again. We are having plus 7 to the power of 7 here, and we are having plus 7 to the power of 7. So this and this will leave. So on the right-hand side of the equation, we are left with just 0. So we now have this to be our 7 times 7. This will give us 49 m, then bracket our m plus 7 close bracket, bracket our m to the power of 2, then plus, here we have 7m plus 7 to the power of 2 will give us 49, then close bracket, all raised to the power of 2, then here we have nothing, so this equal to 0. Okay, so with what we have in here now, here we want to apply what we call the zero property, whereby we can equate this, we can put this in bracket, we can equate this to 0, we equate this to 0, and we equate this to 0. So we have 3 cases here. So let's take the first one. So we have case 1. So our case 1, we have 49 m to the power, equal to 0. So if we divide by 49, automatically we're going to have m is equal to our 0. So this is our m1. So m1 equal to 0. Does it satisfy the original equation? Let's check it out if it will actually satisfy the original equation. So from here, we have 0 plus 7, that will give us the raised to the power of 7, that will give us 7 to the power of 7, right? Then if we come to this other side, we have 0 to the power of 7, that will give us 0. Because 0 to the power of any number, or 0 raised to any number is 0, except our 0 and iota. Then we have here 7 to the power of 7. So we're going to end up having 7 to the power of 7 equal to 7 to the power of 7. So now let's take our second case scenario, which is this. We'll have here case 2. So our case 2, we're going to take here, which is our m plus 7. M plus 7, this is 7, please, equal to 0. Okay, so let's continue here and see what this gives us. All right, now from here we have m. Let me rewrite this. This is equal to 7. So move this to this other side. So we're going to have 7 is equal to minus 7. So this is our m2. So this is m2. All right. So if we also check if this will satisfy this equation, you discover that it will satisfy the original equation, because if we put in minus 7 here, so minus 7 plus 7 will give us 0. The 0 to the power of 7 will give us 0. Then we have here minus 7 to the power of 7, then plus 7 to the power of 7, that will give us 0. Okay, so it shows that this also satisfies the original equation. So we take the third case scenario here, which is our, let's take it here, our case 3. Our case 3, we have our expression, which is m to the power of 2, then plus our 7m, then plus our 49. This is equal to all raised to the power of 2, okay? But let's keep that. So if we are to raise this to the power of 2 and we send it to 0, then we take the square root of both sides, we are going to end up having just 2 solutions from here. But let's keep this aside, okay? Because at the end, we're going to have 4 roots from here, plus the other ones we'll solve for. That should give us our 6 roots. And why are we having 6 against the 7 we are supposed to have here? Because if we use this to open this, we're going to have m to the power of 7 from here, and we also have m to the power of 7 from here. So one of them, we cancel the other one. There we are now left with just 6 roots to this challenge. Okay, so if we have to solve this, we are going to use the formula method. Using the formula method, we're going to have our m is equal to minus our b plus minus the square root of our b squared minus 4ac, right, all over our 2. So because of space, let's come back to this place here. So if we substitute, we're going to have our m will now be equal to, yeah, what is our b? Our b is 7. So we're going to have minus 7 plus minus the square root of our 7 to the power of 2 minus 4 times our 1 times 49. Okay? Everything all over 2 times 1. So if we simplify this here, we can express 49 as 7 to the power of 2. And so this is going to give us minus 7 plus minus the square root of, here we have 7 to the power of 2. And because we can express this as 7 to the power of 2, so we're going to bring 7 out. And if we factor out, we're going to have here 1 minus our 4, those brackets, all over our 2. So because this is square root, the square root, and here we have square here, so that can come out. So if that comes out, then we're going to have here our minus 7 plus minus our 7. Then we are now left with 1 minus 4, which will give us minus 3. And minus 3 can be written as minus 1 times 3. And if we bring in our iota, we say that if we have your square root of minus 1, this is equals to our iota. And so this expression can be written as our iota root 3 all over our 2. So we have two roots from here. We have our m3 and m4. But remember, this is raised to power 2. Now look at it here. This is raised to power 2, right? So we are going to have this expression into two places. In other words, we're going to have 4 roots from here, plus the existing 2 we have here. That will give us 6 roots for this a polynomial equation. Okay, so this brings us to the end of this math class. So we have 4 roots as a reminder from here. Then we have this and this. We have this nice polynomial equation before us here. It's a 3rd degree polynomial equation. The question is m to the power of 3 minus m to the power of 2 minus m equals to 15. What is the value of m that will satisfy this challenge here? All right, so we are made to understand that the highest power of every polynomial tells the number of roots to that polynomial equation. And here we are having 3 as the highest power, okay? Okay, so how do we get the 3 solutions to this polynomial equation? Yeah, I'm going to use an approach which I found very facilitating to solving this challenge in here. So let's take our solution here. Right, if you see us for the very first time, this is Online Maths TV, and we are always online. We are always releasing videos, and if you not subscribe to our channel. And when you subscribe, do not hesitate to hit the notification button. That is only when you get notified when we release an amazing video, because we release videos all the time for our learning. Now we have this question in here. Now let's put down our m to the power of 3, then minus m to the power of 2 minus m equal to our 15. Now look at what I did in here. I just have to look at this our 15 here. If I decide to rewrite 15 here in this format, will it work out? Yes. Now, if I decide to put in here 2 to the power of 3 minus 2 to the power of 2 minus 2, would that give us 15? Now, let's check it out. 2 to the power of 3 will give us 8. Then minus 2 to the power of 2 will give us 4. So 4 minus 8. Then 2 to the power of 1 will give us 2, and 2 minus 4 will give us our positive 2. But here we have 15. So that will not work out. If I decide to increase it to 3, let's see if it will work out then. Then we have our 3 to the power of 3 will give us 27. Then we have minus 3 to the power of 2, which is our 9. So give us our 18, positive 18. Then we have our 3 to the power of 1, which is 3. Then will give us 15. Good. So we got an expression of this kind. So we just have to rewrite this 15. And so this is going to give us our m to the power of 3 minus m to the power of 2 minus our m is equal to our 3 to the power of 3 minus 3 to the power of 2 minus 3 to the power of 1. This is good. So the next thing we're going to do here is to move all quantities on the right-hand side to the left-hand side of the equation. And in doing that, we have to move them according to their powers. We're going to marry them according to the powers they have in there. Here we have m to the power of 3. We have 3 to the power of 3. Okay? So from here, we move this and marry it with this. So this is going to give us m to the power of 3. Then this is positive, it turns to minus our 3 to the power of 3. There's a reason for bringing them, matching them according to their power. And so we come to this next one, we have minus our m to the power of 2. Then I bring this is negative, so it turns to plus our 3 to the power of 2. Then here I have minus our m, here it turns to positive, so plus our 3, everything equals to 0. Nice. Now, I can put this in bracket, put this in bracket, put this in bracket. But putting this in bracket, yeah, this sign will be affected. It will turn to a minus sign, and this will equally turn to minus sign. So let's go ahead and rewrite this. So we have 3 to the power of 3, or in bracket, then minus bracket m to the power of 2 minus our 3 to the power of 2 close bracket, then minus 3, our m minus our 3 equal to 0. Are we getting something from here? Good. Here we have a difference of 2 cubes, and here we have a difference of 2 square. So what does the law say? For the difference of 2 cubes, it says that if you have your, let's take our x to the power of 3 minus y to the power of 3, this is equal to bracket between x minus y close bracket bracket our x to the power of 2 then plus our x y then plus our y square close bracket. This is what we call difference of 2 cube. Then we have difference of 2 square. Difference of 2 square says that if you have your x to the power of 2 minus y to the power of 2, this is equal to bracket between your x, then plus y, bracket, bracket, x minus y. So these are the two algebraic identity we are going to introduce into this system here. So introducing this in here, this is going to give us bracket our m minus our 3 close bracket bracket our m to the power of 2 then plus our 3m then plus our 3 to the power of 2 close bracket minus. Then we're going to apply difference of 2 square, which is our m plus our 3 close bracket bracket our m minus 3 close bracket then minus, here we just have our m minus 3 close bracket, everything equal to 0. Easy. All right. So what we do next here now, if you look critically, you discover that from here we have m minus 3. Here we equally have m minus 3. And here we have m minus 3. So what we do when we have situations of this kind, we just have to factor out m minus 3 that is common to all terms. So we're going to have here our m minus 3 close bracket. Let's bring in a square bracket here. If we use this to divide everything here, we are now left with our m to the power of 2 plus our 3m, then plus here we give us our 9 close bracket, then minus. We use this to divide this, we are left with our m plus our 3 close bracket. Then we use this to divide this, we are left with just 1. We close our square bracket, everything equal to 0. So what we do, we can now open the terms we have inside the square bracket in here. So if we open up this is going to give us our m minus our 3 close bracket, then bracket our m to the power of 2 plus our 3m plus our 9 minus, because we use this minus to open this, so this is going to give us minus m, then minus 3, then minus 1 close bracket equal to 0. Okay, so let's look at it again. Now we can add this and this, and this. Okay, if I add all this together, yeah. So this is going to give us our bracket, our m minus 3 close bracket. Okay, bracket. Here we have just m to the power of 2. So we have plus 3m minus m will give us our plus 2m. Then plus 9 minus 3 will give us plus 6 minus 1 will give us plus 5. So we have here plus 5. Everything equals to 0. So let's continue on this side and see what this gives us a 10. Okay. In this regard, we have what is called the zero property. The zero property says that if you have your x times your y equal to 0, it means, or this implies that your either x is equal to 0 or y is equal to 0. This is what we call the zero property. Okay, so if we apply the zero property here, we're going to have the first case scenario and we're going to have the second case scenario. So let's take case 1. So our case 1, we're having our m minus our 3 equals to 0. So if we move this to this side, we have m is equals to 3. So we have our m1 is equal to 3. And if you substitute 3 into the system, you get the answer. It satisfies the original equation. Now, how do we get the other two roots? We're going to get it from this quadratic equation here. So our case 2, we have our m to the power of 2 plus our 2m plus our 5 equal to 0. So in this case, what we do here, we want to use the formula method. So applying the formula method, we're going to have our m is equal to minus b plus minus the square root of our b squared minus 4ac, right? All over 2a. Simple. Okay, so we just have to substitute into the system. If we substitute, this is going to give us our, what is our b? Our b is positive. So this is going to give us plus 2, minus is going to take minus because we have minus in the system. So we have here minus 2, then plus minus the square root of our 2 to the power of 2, then minus 4 times a is 1, then times our c is 5. Then everything all over 2 times 1. Okay, your dot there is multiplication. Okay, so with this, so what we do is pretty easy. So we're going to have here minus 2 plus minus the square root of, if you check out this, we don't need to multiply this out, okay? But if we do, it will still give us the same thing because here we're going to have 4, so we can factor 4 out of the system, okay? But yeah, let's just go on. So this is going to give us our 4 minus this will give us 20 all over our 2. So let's continue here. So we're going to have here minus 2 plus minus the square root. 4 minus 20, that will give us minus 16. So we have here minus 16 all over 2. Now, we can simplify this minus 16. Let's continue here. We're going to make use of this simple space here. Okay, so the square root of minus 16 can be split into minus 1 times 16. And the square root of minus 1, we know that the square root of minus 1 is equal to iota, right? Good. And the square root of 16 is 4. So we can rewrite everything here. This will now give us our m is equal to our minus 2, then our plus minus our 4 iota all over 2. If we factor out 2 from this, then we're going to have our 2. Okay, let's bring out 2 here. 2 into this will give us minus 1 plus minus our 2 iota all over 2. So this leave the system. So we're going to have our m2 is equal to minus 1 plus 2 iota. And our m3 is equal to minus 1 minus 2 iota. So these are the 3 roots to our challenge. The first one is our m1, which is positive 3. The second one is m2, which is minus 1 plus 2 iota. And the third one, which is minus 1 minus 2 iota. And those are the 3 roots that actually satisfy this polynomial equation, this third degree order polynomial equation. So if you have any question with regards to this question, drop it in the comment section. If you're not clear, also drop it in the comment section. You have a better way of solving this, conserving time. Drop it in the comment section so that Online Maths TV can actually learn from you. Yeah. Okay. Thank you for being there all the time. We love you and we keep loving you until the end of time. Hello and welcome to today's math class. Today we have this challenge before us here. The question is 6 to the power of m minus 5 to the power of m equal to 11. And here we are told that m belongs to a set of positive integer. Okay, so we have to look for the integer solution of this challenge and the positive one of it. Okay, now on this channel I have produced a video of this kind where I solve a similar challenge of this kind here. Okay, let's check out the question here. Okay, so this question I actually solved it about almost 2 years ago, and the question has gotten about 2.8 million views. And one of these days, I decided to scroll through the comment section. I saw so many criticisms, and also saw so many persons that actually gave the approach I applied kudos. Okay, I'm going to give a better explanation of some of the steps I skip in that video also. And if you've not watched that video, okay, it's going to display. Yeah, that's the video showing up here now. Okay, you can click on it and watch it to see what I actually did here. And I want to believe one of the first persons to bring that challenge on the internet, sorry, on YouTube, okay, on YouTube. And since then, many persons have copied that same approach. And from all the criticism, I have not really seen someone who solved that same challenge using an approach different from the one I applied. Okay, so here I'm going to solve this here using similar approach to the first one I solved. Now, if you check out this question here, you'll discover that we just mere guessing you can get the answer to this. Because here we have m here we have m here, and so we can decide to take the value of m ranging from 0 to any other number, because here they said m is a set of positive integer. Okay, so if we decide to put a 0 here, put 0 here, that will give us 1 minus 1, which will give us 0, and that is not 11. And so we increase it to 1. So if it's here is 1 and here is 1, this will give us 6 minus our 5, and that will give us 1. But here we have 11. What if I decide to put in 2 in here? That will give us 6 to the power of 2, which is 36, and 5 to the power of 2, which is 25. And 25 away from 36, that will give you 11. And so 2 is the value of m that will actually satisfy this challenge here. But in case of entrance exam where you are made to show your solving on how to get that value 2, how do you go about that? That is the essence of this video clip. All right, so let's take our solution. Now, the first thing we're going to do here is this. Let's put out the question we have here: 6 to the power of m minus 5 to the power of m equals to 11, right? Good. Now, yeah, I'm having a minus sign here, right? Okay, so what I did in that former question, that former video, is that I try to raise this power and this power to a particular number that will actually lead us to a special algebraic identity. And the thing I thought of, or the identity I thought of, is that of difference of 2 squared. Okay, we equally have difference of 2 cube, right? So if I decide to raise this to, let's take here our 6 to the power of m, or raised to the power of 1, then minus 5 to the power of 6 m raised to the power of 1 equal to 11. This has not really changed a thing. Now, this one can equally be expressed as 2 all over 2, or 3 all over 3, or 4 all over 4, 5 all over 5, right? Good. Now, I raise this to 2 all over 2. In order for me to get my difference of 2 squared from this place, and it works out. And after solving using 2 all over 2, I tried for the one of 3 all over 3. It didn't work out. I tried the one of 4 all over 4. It worked out, okay? It worked out, but it stressed me in getting the answer, okay? I passed through so many steps in getting the answer, but I still got the actual answer to it when I put in 4 all over 4 here. Okay, 5 all over 5, because of, to get the algebraic identity that has to do with the power of 5, we also prolong the solving. And so I decided to raise this to 2 all over 2. Okay, so this is same thing as 6 to the power of m, or raised to the power of 2 all over 2, which is same thing as 1. Then I do same thing here of 5 to the power of m, or raised to our 2 all over 2 equal to 11. The question you may ask again is that why am I not raising this to 2 all over 2? Mind you, what I did here has not actually affected anything. According to the law of equation, it says that whatever you do to the left-hand side, you must do to the right-hand side. Like I said earlier, 2 all over 2 is 1. So it didn't change anything here. Okay, good. So from here, I apply a simple law in indices, which says that if you have your k to the power of your m, then times n, this is equal to your k to the power of m, or in bracket raised to n. I can interchange the position here. So if I switch in this inside, this is going to give k to the power of n, or raised to the power of m. So this is a simple law in indices, right? So I can shift in this inside, leaving this outside. Why am I doing that? Mind you, we are working towards a thing, which is the difference of 2 square. Okay? We know, or we have an idea of the difference of 2 square, which says that if you have, let's take if you have x to the power of 2 minus y to the power of 2, this is equal to your x plus y close bracket, bracket x minus y close bracket. This is what we call difference of 2 square. Okay, so that is what we're working towards to bring out. And so I'm going to multiply this to give me 6 to the power of my m all over 2, all raised to the power of 2 minus my 5 to the power of m all over 2, all raised to the power of 2 equal to 11. All right. So with this, we now have our difference of 2 square here, which is what we have in here now. But before that, to avoid the writing of 6 raised to the power of m all over 2 and 5 raised to the power of 5 all over m, I want to do a simple substitution here. Okay, so I will say here, let 6 to the power of m all over 2 be equal to, let me say, p, and my 5 to the power of m all over 2 to be q. So if I have that to be so, what am I going to do here? So I can put this in here, put this in here. So this now implies that my p to the power of 2 minus my q to the power of 2 is equal to 11. Okay, so what we do next here now is to go ahead and apply this rule here. So if we apply this rule, so we're going to have our p minus, let's take plus our q close bracket, bracket p minus our q close bracket is equal to 11. Now we have the left-hand side, the right-hand side of the equation to be an odd number, right? So since it's an odd number, and here we are having p plus q, we have to look for the factors of 11. 11 has just 2 factors, which is 1 and 11 itself, which makes it a prime number. So if we are to rewrite this as our 1 times 11, this, is it going to be equal to 1, or this will be equal to 11? We just have to decide. Okay, good. Because since we don't have even number in the midst of 1 and 11 there, so we just have to think of the one that will be of the higher value and the one that will be of the lesser value. So if you look here, we are having p here, we are having p here, we are having q here, we are having q here. So this is the sign we have in between. If you check carefully, if we are having p plus q and p minus q, this is summation. So the summation of these two quantities will be far greater or higher than the subtraction we have in here. Why? Because we have p plus q greater than our p minus q. So if it is true, then this will take this, and this will take this. And so this now implies that we're going to have our p plus our q would be equal to 11. Let's take this equation 1, and we have our p minus our q will be equal to 1. Let's take this equation 2. Now, again, because we are looking for just the positive integer or the integer solution of this challenge here, that's why, if not, there are other fractions we can multiply together to give us 11. But because of what we are asked to look for, that's why we restricted ourselves to only 1 and 11. Okay, now from here, this is a simultaneous equation. So we can solve this by either subtracting equation 1 from equation 2 or adding equation 1 from equation 2. But there are laws in solving this. Okay, the law says that when you have this to be plus and you have here to be minus, then you add. But if you have here to be minus, minus, you subtract. If you have here to be plus, plus, you subtract. Okay, so since this is plus minus, we want to add. If we add this will leave the system and we are left with what? 2p is equals to, we add this together, will give us 12. Divide by 2, we divide by 2. Cancel out. Here we have 1, here we have 6. So we have p is equal to our 6. So we've gotten the value of our p to be 6 already. Going ahead to solve for the value of q is of no use. Why? Because we can substitute this value into this substitution we made here and we get the value of m from there. And if we get the value of m from here, the value of m is same thing we're going to get from here if we go ahead to solve for the value of q from this place here. Okay, so with this, let's put this into this equation. So we now recur that our 6 to the power of m all over 2 is equal to rp. So substituting this is going to give us 6 to the power of m all over 2 is equals to p is what? 6. Easy. Now the base number on the left hand side is same to that of the base number on the right hand side. And mind you, 6 could be written as 6 to the power of 1. So since the bases are the same and they are greater than 0, then what happened? This leaves the system. And if this leaves the system, then we can equate the exponent. So we're going to have our m all over 2 is equal to 1. Multiply both sides by our 2. This will give us m is equal to 2. So m equal to 2 is the solution to this, as I said earlier on. Okay. Hello, welcome to today's math class. Today we have this challenge before us here. How do we solve this challenge here? X to the power of 3 equal to 3 to the power of x. This is a simple one. Many looking at this challenge, you discover that 3 is one of the roots because here we have to solve for a minimum of 3 roots to this challenge here, okay? Minimum of 3 roots to this challenge. And so if we got this to be 3, let's check if it is actually correct. If we put in 3 here, that will be raised to power 3. And 3 to the power of 3, that will give us 27. And here, if we put in 3 in place of x here, so 3 to the power of 3, that is also 27. So x equal to 3 is one of the roots to this challenge. But here we can equally get infinite solution or roots to this challenge here. I'm going to use 2 methods in solving this. One of them will just give us one of the roots, which is x equals to 3, and the other one will give us the pattern or the solution to other roots. Okay, so let's take a selection here from here. Now, the question here is x to the power of 3 equal to our 3 to the power of x here. Being that we are having our power on the left-hand side to be 3 and the power here is x, I want to eliminate this and also eliminate this. And how do I go about that? I will multiply these two powers together, find the reciprocal of it. So the answer I'm going to have here, I'm going to raise it to both powers on this question. And so here I'm going to have here x raised to the power of 3, or in bracket, like I said, multiply this by this will give us 3x. Find the reciprocal of 3x, that will be 1 all over 3x, right? This is equal to, I do the same thing to this side here, 3 to the power of 3x, or raised to the power of 1 all over 3x. Okay, then from here, we apply a simple rule in indices, which says that your a, okay, to the power of your m times n could be written as a to the power of your m, or in bracket, raised to n. We can actually bring this in and take this out to give us here our a to the power of n, or raised to the power of m. So we can use this to multiply this. And if we do that, what happens? This 3 will go with this 3. And here, this x will go with this x here. So we are now left with our x raised to the power of 1 all over x, equal to our 3 raised to the power of 1 all over 3. Now look at what we have here. Now the base alphabet and the base numeral. Here we have x as the base alphabet raised to 1 all over x again. Here we are having 3 as the base number raised to 1 all over 3 here at the power. So what it implies is that we can equate the base or we can equate the exponent. So if we equate the base, that will give us x is equals to 3. So from here, it always means that our x is equal to 3. So this is one of the roots that satisfy this exponential challenge here. Okay, all right. Now we want to use the other method that will give us the method, or that will give us a solution to infinite numbers of roots to this expression. So let's take it on this other side here. Sorry. Okay, so we have our x to the power of 3 equals to our 3 to the power of x in here. Now from here, this is what we want to do here now. I want to eliminate this 3 here. And how do I eliminate this? I'm going to raise both powers to 1 all over 3. And so this is going to give x to the power of 3 all raised to the power of 1 all over 3. This is equal to 3 to the power of x all raised to the power of 1 all over 3. And so if we apply this rule, this and this will leave the system. We are now having x is equal to, if we use this to multiply this, we're going to have 3 raised to the power of x all over our 3. Good. I just want to rewrite this expression in here. Applying a rule which says that if you have your e raised to the power of, let's take ln of a star, this is equal to your star. Because this is ln base e, and so this e will cancel out the log ln base e there, okay? And so if we have this to be this, I can rewrite this, bringing in log and ln here, because the essence of doing this is that I want to use the Lambert Wm function in evaluating this, and that will give us a model that will enable us to solve for all infinite, or more or less a good number of roots to this challenge here. All right, so this is going to give us x is equal to e, okay, this e, please, e raised to the ln of whatever we have here, 3 to the power of x all over 3. Simple. Now this is log 3 raised to the power of x base 3. Sorry, all over 3 rather. So this is power. Okay, let us see. Let's put this in bracket. So if we apply the law of logarithm, which says that if you have your ln of your a, okay, all raised to b, I said this is equals to, move this b back here. Okay, so this will be b times the ln of our a. Okay, so we can move this power back here. And so this is going to give us our, let's take our x here, is equals to our e raised to our x all over 3 times the ln of our 3. Good. So with this we have in here now, I want to divide both sides by the quantity on the right hand side. So I want to make this side to be unity. Okay, so from here I'm going to divide by my e raised to x all over 3 times the ln of 3. I will equally do same thing to this side. E raised to x all over 3 times the ln of our 3. Okay, so let's just manage this here. So what happened? This will go with this. So here we have 1, 1. Right? Good. So from this expression here now, I'm going to have here x all over e raised to x all over 3 times the ln of 3 bracket equal to 1. Good. I want to move this quantity backward here, or to the top here. And so we have another rule which says that if you have, let's take 1 all over a, this is equal to your a raised to minus our 1, right? Good. So if we apply that rule, then we can rewrite whatever we have in here. So rewriting this is going to give us our x times Okay, everything we have in here, so we have e raised to the power we take minus, mind you, and the power is the whole of this. So this is going to give us minus our x all over 3. This is 3 please, all over 3, then times the ln of 3 close bracket equal to our 1. Wow. Now, there is something we want to evoke in here, which is the product log or the Lambert W function, Lambert Wm function, which says that if you have your star, okay, times your E, okay, raised to a star, and you decide to take the product log, the Lambert W function, this is going to give you a star. Okay, so if this is true, it means whatever we have here must be equal to whatever we have in here. So let's look at this here now. We are having x here, we have x here. So the difference between this and this is just minus 1 all over 3 ln of 3. So we want to multiply both sides of the equation by minus 1 all over 3 ln of 3. So if we do that, this is going to give us our minus 1 all over 3. We have x here already. Then the ln of our 3 close bracket times our x times our e all raised to the power of minus x all over 3 times the ln of 3 close bracket. This is equal to, we multiply everything we have in here, same thing here. So we have minus our 1 all over 3, okay, times the ln of 3. All right, so let's manage this place here. What to believe is still visible, right? Okay, so with what we have here now, we can rewrite this expression. So this is going to give us our minus x all over 3, the ln of our 3, okay, close bracket, times our e raised to minus x all over 3, then times the ln of 3, close bracket, equal to our minus our 1 all over 3, then ln of our 3. Okay, we are heading somewhere, right? Good. So with what we have here now, you discover that what we have at the base here, same thing we are having at the top there. And so we can bring in the Lambert W function. Okay, so from here, we now have here the Wn function of whatever we have here, our minus x all over 3 times the ln of 3, okay, times e raised to minus our x all over 3, then times the ln of 3, yeah, close bracket is equals to, we do same thing, the LW function of our minus 1 all over 3, then times the L of our 3, close bracket here. Oh, so what happened? Everything here will now give us here our minus x all over 3, then ln of 3 is equals to the Wn, okay, function of our minus 1 all over 3 into our x. Okay, so we are looking for x here. All we just have to do is to multiply first by this 3 here. Okay, so if we multiply both sides by 3 here, it's going to give us minus our x, then times ln of 3 close bracket is equals to 3 into our Wn of our minus 1 all over 3, then times our ln of 3. Good. Now, we are looking for s. We just have to divide by minus ln of 3. So if we do that, we're going to have our x is equal to our minus, because this minus and this we're going to use to divide this. So this is going to give us minus our 3, the Wn of our minus 1 all over 3, then ln of our 3, close bracket here, right? Everything all over our ln of our 3. Now, what is n? Where n is equal to 0, 1, 2, 3, dash. Okay, so that's why I say from here we can get infinite solution to the value of x that will actually satisfy this equation here. Okay, although there are some values that will not satisfy the equation, but from here you can vary your n. Okay, so range it from 0 down, then you get so many of them. So one of the roots I got from here when I substitute we have x is equals to our 2.478 052. Okay, this is one of the root I got when I substitute it into the formula here. All right, so with this we can actually get infinite solution to our x here for this challenge. All right, so thank you for being there. You have a question, drop it in the comment section. See you in our next class.